Hello student. In last lecture, we have discussed JK flip-flop. A flip-flop has no disadvantage. No forbidden state as well as two input circuit. And one major advantage is toggling. What is toggling? Toggle means switch to opposite state. If in previous stage Q is 0, then in next stage Q become 1. If in previous stage Q is 0, then it become 1. If it is 1, then it becomes 0. That is said to be toggling. If in previous stage Q is 0, then in next stage it become 1. This is the meaning of toggling. But let us assume that if toggling occurs twice in one cycle, then from 0 to it become 1, and again from 1 it becomes 0. And this action is completed in nanosecond. Nanosecond means 10 raised to minus 9 second. So we are not able to visualize it because our eye doesn't have capacity to measure the timing of nanosecond. Or even if you have a LED or LCD screen, they are not in the position to notice that one. Even in your CRO, cathode ray oscilloscope, is also not able to measure this timing. So this is the only disadvantage of JK flip-flop, that if toggling occurs twice in a cycle, then Q retain the last state. Suppose if it is 0, then on first toggling it should be 1, and on second toggling it become 0. Or if it is Q is 1, suppose in previous stage, then on first stage it becomes 0 and then it becomes 1. Normally this type of things not happen, but there are few chances are there that if toggling occurs more than 1, then this problem arises, and the name of this problem is racing. Name of this problem is racing. What is racing? Toggling more than once, that is racing. Toggle more than once. Toggle more than once is racing, and this is the only disadvantage of JK flip-flop, and very easily we can eliminate this problem with the help of MS-JK flip-flop, master-slave JK flip-flop. Master-slave JK flip-flop. With the help of MS-JK, we can eliminate the only disadvantage of JK flip-flop, that is of racing. So in today's lecture, in the first part, I am going to discuss MS-JK flip-flop. Now, the circuit of MS-JK is very simple. You have to draw the symbol of JK flip-flop. J, K, Q, Q bar, J, K, Q, Q bar, Look at the circuit of master slave JK flip flop. Master slave JK flip flop. First one is a master, second one is a slave. What is the difference between these two symbols? The symbol is the way in which we have applied the clock pulse. The first one, that is a master, is positive age triggered. Second one is a slave, is negative age triggered. Now, what is the difference between positive age triggered and negative age triggered? That I have explained in the first lecture of this chapter. Again, I am going to explain you. Suppose this is your clock pulse. Then this part is said to be positive transition. 0 to 1 is said to be positive transition. So, master works in this part. This part 1 to 0 is said to be negative transition. This is a negative. This bubble shows it is a negative age triggered. That part also we have discussed in the function of preset and clear of D flip flop. So, overall, this is a circuit of master slave JK flip flop. Both the flip flops are JK. Master is positive age triggered, while slave is negative age triggered. Master works on the positive transition of a clock pulse. Slave works on the negative transition of the clock pulse. So basically, slave copy the action of master. Okay, now truth table. Truth table is exactly same as of JK flip flop. J, K, Q of n plus 1 and action. Clock is 0. J and K input doesn't have any impact. Flip flop is in no change condition, or we can say that it is a last state. When clock pulse is available and both are 0, J is 0, K is 0, the result remains same. It is a no change condition, or we can say that last state. Because ultimately the things remain same. One input of AND gate is 0, so finally it is the last state. Now when the clock pulse is 1, it is 0 and 1. It is 0 and 1. So you can say that during the positive transition, master is reset, and during the negative transition, slave is reset. So that means you have dual action in one cycle. So there are no chances that circuit toggles 2 times, because already in one pulse, in the initial part master works, in the second part slave works. So that in this way we have eliminated the problem of racing. Same way, if it is 1 0, J is 1, K is 0. So during the positive transition, master work, during the negative transition, slave work, and Q of n plus 1 become 1, and you can say that this one is set. And the last one, clock is available and J is 1, K is 1. So, during the positive transition, master toggle, during the negative transition, slave toggle. So, there is no chances of racing, and the only disadvantage of JK flip-flop is very easily eliminated. So, nowadays in place of JK flip-flop, people are using master slave JK flip-flop only for the property of toggling. That is a unique property of the JK flip-flop, that Q must be complement of Q bar. And that is why in previous stage Q is 0, in next stage it become 1, and that is toggling, switch to opposite state, and that is why people are using this one. So, for that the symbol is slightly different. For master slave JK flip flop, this is master slave JK flip flop with active low preset and clear. So, for normal operation you have to kept it 1, and if you want to utilize this preset facility, then you have to make preset 0. If you want to utilize clear facility, then you have to make clear equals to 0. So, this is a symbol of master slave JK flip flop. So, 3 families over: RS, D and JK. Especially D is used when the single input is required, and JK family is used when we want to use the toggling facility, switch to opposite state. Now, one more topic we have to discuss today, and that is flip-flop switching time. See, timing is very important in our day-to-day life as well as in electronic circuits. In this topic, we are going to discuss 3 different timing flip-flop switching time. The first time, propagation delay time. See, basically all these flip-flops are designed with either diode or transistor. Diode or transistor, that is said to be the active device. They are going to take some time to change the state. Suppose initially diode is off and then it become on. Before, in this action, they required some timing. That time definitely is in terms of nanosecond. 1 nanosecond means 10 raised to minus 9 second. It's a very less time, but this time diode or transistor take to change the state. And this timing is main cause for the propagation delay time. The minimum amount of time that required by a flip-flop to change its output is called propagation delay time. Suppose in previous stage I am using the word, suppose in previous stage q is 1 and then on next pulse it becomes 0. The time required to change this state from 0 to 1 or from 1 to 0 is said to be the delay time, propagation delay time. A minimum amount of time required by flip-flop to change the state is called propagation delay time. The minimum amount of time required by flip-flop to change the state is called propagation delay time. This delay time is normally represented in this way, Tp, and normally it is in the order of 10 nanosecond. It is in the order of 10 nanosecond. This is the first time, propagation delay time. A minimum amount of time required by the flip-flop to change the state, to change the output, is called propagation delay time, and that is 10 nanosecond. Second time, setup time. A minimum amount of time that data must be present before the clock pulse arrives. A minimum amount of time that data must be present before the clock pulse arrives. This word is important. The minimum amount of time that data must be present before the clock pulse arrives. So, before the clock pulse, data must be present, and that time is known as setup time. Normally, this setup time is 15 nanosecond. Delay time 10 nanosecond, setup time 15 nanosecond. And the third time is the hold time. A minimum amount of time that data must be present after the clock pulse arrives. So, even after the clock pulse arrives, data should be there. Definitely, that hold time is not of 15 nanosecond, it is 5 nanosecond. The minimum amount of time that data must be present after the clock pulse arrives. Before, then it is set time, after, that is a hold time, and time required to change the state, that is known as delay time, propagation delay time, TP. So, these are the three timings that it must be present over there. So, if with the diagram I can explain you, suppose let us say this is a clock pulse, this time is set up and this time let us say hold time. This is data input, this timing is known as setup time. This is a clock pulse, the time required before the clock pulse arrives, time required after the clock pulse arrives, and this timing is known as propagation delay time. This timing is known as propagation delay time. Clock pulse, the time before is setup, time after, that is hold, and after the clock pulse, and here the circuit has changed the state, that is known as delay time, propagation delay time. So, these three timings are very useful. They can ask this question in short note or in 1 mark section also it is asked. Propagation delay time, setup time and hold time. The time before the clock pulse arrives, data must be present, is setup time. Hold time means the data should be there even after the clock pulse arrives, is the hold time, and time required to change the output after the clock pulse arrives. So, internal time consumed by the circuit is known as delay time. So, this timing is also connected with you also. Suppose I am a clock pulse, teacher is a clock pulse, student must be present before the teacher enter in the classroom, that is setup time. Student must be present before the teacher arrives. Student should be there, that is hold time, and after the lecture first teacher goes and student, that is hold time, and delay time, to understand the lecture, the time consumed by the student, that is the propagation delay time. Normally for this flip-flop, we have studied this flip-flop based of TTL family, transistor logic, and all the ICs are of 74 series. 7400 is a NAND gate. Normally this NAND gate is used to design this flip-flops. So for that, propagation delay time is 10 nanosecond, setup time is 15 nanosecond, and hold time is 5 nanosecond. This question they can ask you in 1 mark question. Okay, so remember all this. Okay, so all the three flip-flops are over. Now in next lecture we are going to discuss one application of this flip-flop. So there are many applications, counter is the one of them, but that is not in your syllabus. So one application is there, contact bounce problem. So how manual circuit problem is eliminated with the help of flip-flop, that we are going to discuss in the next lecture. And then after that one more lecture, that is for SQ part, and then that would be the end of your syllabus of paper 304. So, 2 lectures left for this paper. Okay. Thank you.